My name is Patrick Tomko. I'm an assistant professor of chemistry at the University of Alaska Anchorage. I am the project lead for photo-enhanced toxicity of dispersed and crude oil to Arctic mussels. The project team includes Katrina Cunahan at the Alaska Sea Life Center, Phoebe Zito at the University of New Orleans, and Colin McGill at the University of Alaska Anchorage. The goal of this project is to determine if the toxicity of dispersed or burned oil is different from untreated oil and how seasonal differences in sunlight influence toxicity. Arctic mussels are being used in toxicity tests for this project because they're important food resources for wildlife and humans. Additionally, mussels are ideal for monitoring programs after a spill because they're ubiquitous, sessile, and they concentrate chemicals in the water due to filter feeding. This project's important because the toxicological impacts of dispersed and burned crude oil exposure in the presence or absence of sunlight towards Arctic mussels have never been addressed in the extreme environmental conditions of the Arctic. We're evaluating how these will affect various aspects of mussel health, such as immune function, metabolism, stress response, and detoxification response, and if sunlight exposure increases these effects. The inspiration for this project came from a conversation that occurred at the Alaska Sea Life Center with Katrina Cunahan, who is the director of the Coho laboratory. And she had just recently published a study on the toxicological responses of mussels to crude oil and dispersed oil. And after some conversations, we thought it would be interesting to assess the added response of seasonal sunlight effects. We also were really inspired to start to connect toxicological responses to molecular compositions, and that's been a terrific add-on with our collaborators in New Orleans, who are experts in advanced instrumentation to profile the molecular composition of dissolved hydrocarbons. We're hoping is that the results of this project can be applied to management decisions on the use of recovery methods and to monitor near-shore recovery after a spill. After a marine oil spill, you need to decide whether you want to treat the spilled oil, because 100% of the oil that's spilled cannot be recovered. So you have to decide what you're going to do with the spilled oil. We are assessing the different treatment strategies that people commonly implement, such as adding a chemical dispersant or burning the oil. And we're identifying whether these treatment strategies may cause more toxicity to Arctic marine organisms than no treatment at all. So mussels are collected off of the beach, and then they are placed into an exposure chamber where they're exposed to varying levels of crude oil, dispersed oil, or burned oil. And after defined time intervals, the mussels are removed from the exposure chamber and they are dissected, and the tissues are archived in a -80 freezer and then sent to be analyzed by an assay. Especially in juveniles, the toxicity towards juveniles is significantly higher than those of the adult stage. But we have not noticed significant adult level mortality. We have noticed mostly sublethal responses, and that's what this project is mostly focused on, is the stress that these organisms are exposed to. So one interesting piece that we've found in this study is that the hydrocarbon characteristics vary significantly between summer conditions of 24-hour sunlight to those of complete darkness, where you have 24-hour darkness, which would be representative of an Arctic system. We're also finding that the variation between mussels, between individuals, is incredibly high. So the theoretical results of this project are to provide first responders a decision tree that they can draw from that will allow them to rank the treatment strategy that they will employ in the event of an oil spill. So the categories that this will be split into are the relative toxicity of the treatment strategies to mussels, the time of the year with the sunlight effects, and the chemical composition of the dissolved hydrocarbons. The project began in March of 2019. We had built an exposure chamber, and we collected mussels, and we exposed mussels to each of the treatments in the fall of 2019. After exposure, the mussels were dissected and all of the tissues were sent out to appropriate laboratories. We took water samples and they were sent out to the University of New Orleans for chemical analysis. At this point, we have finished conducting approximately half of our tissue analysis. We have about halfway completed the physiological, the biochemical, and the metabolic assays, and we are proceeding on the chemical analysis. The project goals for 2020 are to complete the physiological and biochemical stress response assays and to complete the chemical profiling of the dissolved hydrocarbons. We hope to synthesize this and produce a knowledge product that has a ranked decision tree matrix by the end of the year.